Welcome to our deep dive on AWS Route 53. Now, if you're a cloud architect, a developer, or you're studying for an AWS cert, you absolutely have to know this service. Seriously, it's the global traffic director for the internet, and it's rock solid. Okay, let's start with the single most important number you need to know, 100%. And no, that's not a typo. Route 53 is one of the very few AWS services that comes with a contractual guarantee that it will never, ever go down. I mean, in a world where we get excited about 5 nines of uptime, 100% is just wow. We'll see why that's so important in a bit. So here's what we're going to cover. First, we'll get into what makes this thing so unbreakable. Then we'll pop open its amazing toolbox of routing policies. After that, we'll see how it literally keeps your applications online. We'll also touch on bridging the gap between your cloud and on-prem worlds, and we'll wrap it all up with the ultimate cheat sheet for your next exam. All right, let's jump right into section 1. We're going to figure out what Route 53 actually is and why it's pretty much the foundation of any reliable architecture on AWS. So at its heart, Route 53 is a global DNS service. You can just think of it as the internet's phone book, right? It translates the domain names we all know, like google.com, into the IP addresses that computers need to talk to each other. But as you're about to see, this is one seriously advanced phone book. And this quote right here, this is the key. This isn't just some marketing slogan. It's a real contractual promise from AWS. So why does this matter so much? Well, because DNS is the front door to your entire application. If it goes down, nobody can find you. With Route 53, that front door is basically guaranteed to be open always. Okay, now for the really fun stuff, the core functionality. This is where we get to see all the powerful tools Route 53 gives you for directing your user traffic. I mean, this is where the service just shines, giving you this incredible granular control over where your users end up. Think of these routing policies like different tools in a really sophisticated toolbox. Each one is made for a specific job. You've got tools for simple routing, for A/B testing, performance, disaster recovery, you name it. And listen, if you're taking an AWS exam, they're going to give you a scenario, and you'll have to pick the right tool for the job. Knowing these use cases isn't just helpful, it's absolutely critical. Now, let's clear up something that confuses a ton of people. Latency versus geolocation. They sound similar, but they're totally different. Latency routing is all about one thing: speed. It asks which AWS data center will give this user the absolute fastest connection, and boom, sends them there. Geolocation, on the other hand, cares about physical geography. It asks, where is this person on a map? This is super important for things like data laws, think GDPR in Europe, that say user data has to stay in a specific country. And to round out our key policies, we've got 3 more you have to know. First, weighted routing. This is perfect for things like A/B testing, where you might want to send, say, just 10% of your traffic to a new feature to try it out. Then you've got failover, your classic disaster recovery setup. If your main site dies, it just automatically flips over to the backup. And finally, there's multi-value answer, which is a really clever way to do some basic load balancing right at the DNS level without needing a big, expensive load balancer. So you've got all your traffic routed, but what if the server you're sending it to is down? How do you make sure you're not sending users into a dead end? Well, that's exactly where health checks come in. You know, the process itself is just beautiful in its simplicity. Just imagine you have this army of little health checkers all over the planet, and they're constantly pinging your server. All they're looking for is that 200 OK response, which is the universal signal for, hey, I'm alive and well. If they get it, the server is marked healthy. If they get an error or nothing at all, it's immediately marked unhealthy. And Route 53 just stops sending people there. Simple as that. But wait, it gets even cooler. You can go way beyond simple pings and create what are called calculated health checks. This is where you can build some real logic, like, hey, only consider my application healthy if the web server and the database are both healthy. You can even hook it into CloudWatch alarms to trigger a failover based on application metrics, like if your CPU usage gets way too high for too long. It's just incredibly powerful. All right, let's switch gears and talk about a more advanced topic, but one that's super important for bigger companies. How Route 53 helps you connect your shiny AWS cloud environment to your, regular on-premises data centers. It creates this one big, seamless network. The easiest way to remember this is to just follow the direction of the question. Think of it like a phone call. An inbound endpoint is when your on-prem data center calls into AWS to ask for an IP address. An outbound endpoint is the other way around. It's when your stuff in the cloud needs to call out to your on-prem network to find something. It's really all about who's asking the question. And the way you control all this traffic is with forwarding rules. They're basically just simple if-then statements for DNS. You create a rule that says, hey, Route 53, if you see a request for a server ending in .internal.corp, don't even try to answer it yourself. Forward that question over to our on-prem DNS servers, because they're the only ones who know the answer. Okay, let's bring it all home. Here are the absolute must-know facts. If you're walking into a cert exam or a tech interview, these are the points you really want locked and loaded in your brain. All right, let's nail these down. First, the 100% SLA. It's your uptime guarantee it will not go down. Second, you can totally buy and manage your domains right through Route 53, but you can also use it with domains you bought somewhere else. And third, this is a classic exam trick, so listen up. For private DNS inside your VPC to work, you have to enable both DNS hostnames and DNS support. If you forget one of them, it just won't work. So here's the biggest takeaway from all of this. The true power of Route 53 isn't just knowing what each of these policies does on its own. It's knowing how to combine them to solve really complex, real-world problems. Which brings me to one last challenge for you. How would you combine the tools we just talked about to solve this exact problem? I'll let you think on that one. Honestly, working through that puzzle is the best way to make sure everything we just covered really sticks.